Welcome back, everybody. This is Mr. Keeney. We're going to continue our conversation today about geometric proofs. We're going to use deductive reasoning to form these proofs, which are logical arguments. And today, especially, we're going to write proofs. We're going to use theorems, postulates, properties of equality, and congruence as we go. I want to point out that on these notes, I won't have them readily available to me, but I'm going to scroll down to the very end and show you that there is a word bank for the reasons for these proofs that you can have with you. And if you're in class, if you're in person, I actually have them up on our slideshow that we go through. So for those of my friends at home in the online setting, just know that at the very bottom of those, there is the word bank, and I also provide them on our teacher filled out notes as well. So let's go ahead and jump right in. We talked about last time about the parts of a proof, which we can see those here. Just to take a second, and I'll erase this, but they give us a given statement, what we're trying to prove, they give us a picture, and what we want to come up with is the statements, which actually I give you today, you'll see, and then our main job is the reasons that we have to come up with. So I just wanted to point out the parts of our proof one more time. Today, you're going to help me complete my proof. You're going to help me finish my proof. So given example 1, given AB is equal to BC. And now I want to make sure over here that you always mark your picture. So if AB is equal to BC, I'm going to use these little congruency marks, which I know it says equal, but if they're congruent, we also know they're equal. And what they want me to prove is that AC then, which is this whole thing, AC, is going to be equal to AB plus AB. So let's take a look at what Mr. Keeney did. So I first brought it and it says AB is equal to BC, and the reason, and it will always be your first reason, is given. Start with your given information. All right, and the next statement says AC. So now let me bring that up again. AC, this whole thing is equal to AB, and maybe I should use a different color to show you AB, 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 okay, and plus BC. And again, that's equal to AB, and you can see that over here. When I were to combine these together, I'm going to get the same length as AC. Now, the big thing is what gives us that justification? What says that the parts of the segment equal the whole? And this is back from the first unit that we did. It is segment addition postulate. Segment addition postulate says that the parts will add up to equal the whole. Okay, and that's something that we're going to have to work on, but the segment addition postulate is going to be a big thing in our strategy moving forward. Now, we have AC equals AB plus AB, and I want you to look at how I'm changing this here. The only thing I'm changing is that instead of BC, I'm changing it to AB, because I know BC is equal to AB. So instead of BC here, I am changing it to AB. I'm plugging in AB for BC, and that is using substitution. And that gets us what we are trying to prove. So our first proof done, and it's just the 3 steps. We have our given, segment addition postulate, and substitution. So with these proofs, and I know some of you might be thinking, whoa, that's kind of some heavy stuff, and it is. So please be patient. Please keep trying these out and work with me as we go through. Example 2, it says L is the midpoint of KM, and we're given that LM is equal to AB. So something kind of weird here. We see that L is the midpoint of KM. I see that in our first statement, so that's given. But this next piece, LM is equal to AB, I'm just going to point out down here that it is also our given. So we have actually given in 2 spots. You won't see that all the time, but I want to point that out right away. So L is the midpoint of KM. Now look over here. Here's where L is. And if it's in the middle, that means it's the same distance to K as it is to M. And if it's the same distance, what I can say is that KL is congruent to LM. And that's actually what I did here. I said because I know L is the midpoint, I have KL is congruent to LM. That is the definition of midpoint. The midpoint gives us that. If they give you a midpoint, in this case they gave you that L is the midpoint, what we're going to say is that, okay, if I have a midpoint, I have 2 smaller and equal parts. In this case, it was KL and LM. Now, when I'm going to here, If the same two segments, you'll notice that KL and LM, they're congruent. I also know they're equal. That is a new reason. That is called the definition of congruent segments. And that definition says if segments are equal, then they are congruent. If they are congruent, then they're equal. So notice the only thing that's changing is I'm saying that if they're congruent, they're equal. That's the definition of congruent. And then the next one's our given statement. And then finally, I say KL is equal to AB because I took AB and I put it into the spot for LM, which also goes right here. So we're saying substitution. Because I know, and again, just to explain, because I know that KL is equal to LM, and I know that LM is equal to AB, then I can say KL is equal to AB. Substitution, or someone might come in here and say transitive property as well. So I'm going to put transitive property as well. Either one would work. Okay, so there's example 2. Oh, and I needed a tick mark there. Example 2. And now we're on to our last one. I think our last one, yep, example 3. So we have a little picture over here, and what we're given is that measure of angle 2 is equal to measure of angle 3. So I'm going to add little arcs. Maybe I'll do different pictures, or different color because I used red. So 2 and 3 are the same. And I have this word, TV bisects, and we're going to have to know what this means, so we'll talk about it in a second. And that's actually what they start with. You'll see here, TV bisects UTW. That is given. And let's talk what it means. Here is UTW, this angle up here. And it says TV is bisecting it. Bisect, remember, maybe we'll put it up here, bisect. I like you guys to think of it as cut in half. If I'm cutting an angle in half, I'm getting two smaller and equal angles. So notice what I said here. If they're bisecting, then I know, looking at my picture, well, 1 has to be the same as 2. They have to be congruent. That is the definition of not just bisect, but of angle bisector. An angle bisector is cutting an angle in half. That's what gives me the two smaller and equal parts. And now we're going to look here. I'm saying the same thing except for the congruency. I'm saying they're equal, which is the definition of congruent angles. And then I have this statement here, which don't be fooled by it. Don't be fooled. It's just up here. That's our given. Bring it in the given again. And then, so look at these two steps to get to this one. If 1 is equal to 2 and 2 is equal to 3, this is another one of those substitution or transitive. And then if I want to get my proven statement, 1 is congruent to 3, they were equal, I'm going to say that they're congruent. That is the definition of congruent angles. Again, the definition of congruent angles, all it says is if the angles are equal, then they're also congruent. If they are equal, they're congruent. If they're congruent, they're equal. So there is our 2.6 day 2 notes. I know that is quite a bit. Proofs, it takes practice. It takes patience. Please email me, ask me questions. If I can help you, I'd be happy to help. Thank you for watching, and I'll hear from you guys later.